So in our physics video, we hit a bunch of baseballs. We measured the distances that the balls went in steps, but we didn't write down which distance correlated to which video. So we will show you how we used kinematics to find one distance that one ball went, and then found a conversion between steps and meters that we used to find the distance that the rest of the balls went.
So right here we're using tracker to find the velocity of the ball in this frame. We know that velocity is the change in x and the change in time. We use the final distance minus the initial distance over the final time and the initial time. The final distance was 4.32 meters minus negative 1.52 meters over 4.87 seconds and minus 4.69 seconds. By doing this, we found the initial velocity by which the bat hit the ball, which was 32.48 meters per second. We also found the angle at the ball at which it was hit by estimating and using a protractor and sticking it onto the screen, and found that it was 16 degrees.
So in order to get our total distance traveled, we're going to have to add delta x1 and delta x2. So right now we're going to try and break up our initial velocity into its component form. So for vertical velocity, we're going to use a trig function of sine, and when we do that, we're going to end up with about 9 meters per second. And then we're going to do a horizontal component of our vertical velocity, and for that we're going to use cosine. And that should give us about 31 meters per second. So right now we're going to try and solve for time using velocity. And that we're setting the top of our arc as it's moving vertically at 0 meters per second. And right now we're recognizing the ball was hit at a height of 1.4 meters, and we're going to need that later on to solve for our delta x2. So we're plugging in our initial vertical velocity of 8.95 meters per second, and we're going to set our positive and negative directions so we can use gravity correctly. And we're going to multiply the acceleration due to gravity times time, and solving for time we're going to end up with just under 0.9 seconds. And we're going to need to double that because it's a symmetric parabolic arc in order to get the total time. And doing that, we're just going to get under 1.8 seconds.
So now that we find the time, we need to find the distance. So we're going to multiply time times the horizontal component of velocity, because that'll cancel out the seconds, so then we'll only be left with meters. And when we multiply them, we will be left with about 56 meters. Great. So now that we found x1, to find the total distance, we need to find x2. So we're going to set up a triangle, but it's going to be like the opposite of what we used to find the initial components of vertical and horizontal velocity. So now we're going to use the vertical distance and the vertical velocity to find the amount of time it takes for the ball to hit the ground. We can see here that the velocity vector forms the same angle that it did when it was initially hit by the bat, but it's below the horizon. Using the frame of reference that we set earlier, the vertical distance and velocity are going to be negative. So using those values, we come up with a time that's about 0.15 seconds. And then we multiply that times the horizontal component of velocity to find the distance is about 4.5 meters. So the final step is to add x1 and x2, and we end up with a total distance of about 60 meters. So when we were hitting the baseballs, we took multiple videos, but Luke only measured some of them with his steps, so we didn't know which steps went with which video. So we found out that Luke's steps equal about 2.5 feet, which equals about 0.762 meters. So then we multiplied 0.762 times each of the steps that Luke took. And we found out that the video that we chose to work with took about 80 of Luke's steps. And the amount of meters that it was pretty close to the amount of meters that we found using kinematics. Yay, physics!